You have about 2 minutes. The most quoted sentence about this event: a triceratops in Alberta, 3,000 kilometers out, with 2 minutes left before the sky kills it. So you file this one under fast. Single cause, single afternoon. 2 minutes was the merciful version. Almost nothing got it. So what does the killing, if not the impact? Start with the panel, because it is about to be useless. Carbon dioxide, 500 to 1,000 parts per million. A few times home, nothing you would notice. Oxygen, modern, maybe a shade above. Temperature, 4 or 5 degrees warmer than home. Breathe in. It is the best air this season has offered you. Slightly heavy, slightly sweet, entirely survivable. Which is the problem? Nothing that removes 3/4 of the species on Earth shows up on those dials. The number that matters is not a gas. It is a weight, 5 kilograms. Nothing on land much heavier than a house cat comes through. You are 14 of those. So what does the jump put you in? An ordinary day. Hold on to that because it is load-bearing. A shallow coastal plain in the last few thousand years of the Cretaceous. Warm, humid. No ice anywhere on the planet. Forests run to both poles, and a shallow seaway cuts the continent in half. Grass, not yet. Look up. Ordinary sky, ordinary sun, ordinary light on ordinary leaves. And the animals are the ones you came for. Triceratops, Tyrannosaurus, in these same last few 100,000 years. In the water, ammonites, 300 million years of successful engineering, coiled shells the size of a car tire. It is a functioning, crowded, well-lit planet on a Tuesday. Then the southeast lights up. No sound, just light. Second sun, low on the horizon, brighter than the first, a long way past the curve of the Earth. And then nothing. For several minutes, nothing at all. So what is coming if there was no sound? Not a shockwave. The pressure wave arrives eventually, and it is not what kills you. Look at what it did with its energy. A bolide about 10 kilometers wide at 45,000 miles an hour, releasing on the order of 100 million megatons. And it spent most of that not digging a hole, but throwing. Over 50 times the asteroid's own mass, launched as pulverized rock, much of it clean out of the atmosphere. Whatever goes up on that kind of arc comes back down, all of it, everywhere, within the hour. Douglas Robertson and colleagues worked out what that does to a sky. Billions of tons of debris re-entering at once does not flash. It glows. The whole dome above your head becomes a radiator lit for tens of minutes. So step out and look up. You are standing in front of an open oven the width of the horizon, and there is no direction to turn your face away from it. Exposed skin goes in seconds. Your lungs go next. You cannot breathe air that hot without cooking the tissue you breathe with. That is the 2 minutes. Not a blast, a sky. Which means the only thing that helps is what a triceratops cannot do. Get underground, get underwater, get under a riverbank, and stay there. So say you did. You found the burrow, or 3 meters of river, and came back up. What has changed? The light, not gone. Wrong. Dimmer by the hour and heading one way. What went up as pulverized rock is coming down as dust. What is left above the weather is finer, and it is not coming down for years. Julia Brugger and colleagues modeled what follows: a global average drop of more than 20 degrees, years below freezing, 30 before the cooling unwinds. So the injury changes species. A burn is an event, you survive it or you do not, and it is finished. This has no event in it. Stand out at what should be midday and cast no shadow. And underneath, the clock that actually runs this extinction starts. Photosynthesis is not slowed here, it is switched off. On land and in the surface ocean, at once, everywhere. Which means the question has changed shape. It is no longer what the sky does to your body. It is how long your body can go without anything to eat. So why does it stay dark for years? Dust settles. This is where the event stops being about an asteroid. Chicxulub came down on a shallow carbonate platform loaded with sulfur-bearing rock, gypsum. Evaporites. Natalia Artemieva and Joanna Morgan modeled what a target like that releases, and the headline is not dust. It is sulfur, vaporized, thrown into the stratosphere where no weather rains it out. Sulfate aerosol is the most efficient sunlight blocker this planet has, what a large volcano uses to take a fraction of a degree off one summer. This was that, all at once, with no magma chambers setting an upper limit. Tip your head back. The sky is not black. It is the wrong shade of brown, evenly, horizon to horizon. Now the part that changes the shape of the whole event. In 2017, Kunio Kaiho and Naga Oshima asked what would have happened if it had landed somewhere else. They mapped how much of Earth's surface holds enough sulfur and organic carbon to throw a killing aerosol load skyward. The answer came out at roughly 13%. 13%. Earth turns 15 degrees an hour. Half an hour of rotation either way, same trajectory, and that rock goes into deep ocean crust instead. No impact winter. The dinosaurs are fine, so the murder weapon is not the asteroid. 10-kilometer objects are ordinary. Where this one landed is not, which is also why there's nowhere to go. A thermal pulse has geometry. You put rock between yourself and it, which is exactly what the survivors did. Stratospheric aerosol has no geometry. It is over the poles, over the open ocean, and over the burrow you just survived in. So what does an off switch on photosynthesis cost? Start where you would go looking for food. The sea, all season, the water has killed you or fed you. Here it does neither because it empties from the bottom. Around 95% of planktonic foraminiferous species go, the base of the marine food web. Above them, ammonites, every single one. After 300 million years of getting it right. What is left is a Strangelove ocean, productively dead for at least 500,000 years. Wade in and look down. Clear water, and clear because there is nothing in it. On land, watch what grows back first. Ferns. There is a thin fern layer in the rock world wind directly above this boundary. The first thing back is what colonizes burn scars. So look at who is still moving in year 2. The list is narrow. Sheltered. Burrows, mud, fresh water which runs on rotting leaf litter rather than living plankton. Omnivorous in the widest sense, seeds, insects, carrion, rot. That is your 5 kilograms. Not a rule anybody enforced. Arithmetic. A big animal needs a big continuous food supply, and the supply is what's stopped. Even the survivors come through shrunken, the Lilliput effect. Every survivor here got smaller. You cannot. You survived the sky. You found the bank. You stayed down for the 2 minutes. You came back up. And there is nothing wrong with the air. That is the strange part. Carbon dioxide is not lethal. Oxygen is fine. Nothing is poisoning you. You could breathe this air for the rest of your life. It is going to be a short life. Every era this season handed you a variable. Go deeper. Go north. Wait a century. Climb. Stay out of the water. Something moved, and moving along it changed the answer. There is no variable here. It is the same sky over the entire planet, no latitude with light left in it, no season that arrives. No depth, no altitude, no shelter. Because the thing being withheld is not a hazard you hide from. It is a supply. You are 70 kilograms of animal that has to eat, standing in a world where nothing is growing, and it will be years. Nothing you do changes weather, it only changes when. So how did anyone work this out? Late and against real hostility. A geologist called Walter Alvarez was looking at a thin band of clay in a limestone gorge at Gubbio in Italy, the exact line where the Cretaceous stops. His father, a Nobel physicist, suggested measuring its iridium, rare in Earth's crust, common in asteroids. They published in 1980, and a large part of the paleontological profession called it codswallop. A decade of physical evidence settled it. Shocked quartz in Montana, a tsunami deposit in Texas, melted glass in Gulf of Mexico cores. Then the crater, 100 miles across, buried under half a mile of sediment, sitting in 1950s oil survey data the whole time, filed as a volcano. Here is what makes this event unlike the other 4. It has an on switch. The aerosols rained out. The light came back. Within a few years, the sky over the Yucatan was a sky again. Stand in it. Ordinary light on ordinary leaves, and it means almost nothing yet, because the world did not come back with the sun. The ocean stayed dead for 500,000 years. Reefs took 10. What walked out of it on land was small and stayed small, in the dark, eating whatever had already died. One of them was an unremarkable furred, burrowing animal. Every mammal alive descends from something in that category. We keep the famous line because it sounds like the whole event. You have about 2 minutes. For a triceratops in Alberta, that was the entire extinction. For the rest of the planet, 2 minutes was the part that was over quickly.